Excuse me. Thank you very much. I'm really excited to be here. I think we've got a great turnout, and these guys put together a really great event, and I'm excited about that. As they mentioned, my name is Joshua Hoffman, and I am the head of product engineering for LeaseWeb. And in some ways, this talk will be more about what not to do than what to do. Based on my experience and my background and the companies that I've worked for, these are sort of the collection of things that I have seen can really hurt you when you're trying to scale up, and that's really what we'll be talking about today. I think it's important that you know who is speaking to you, and since this is based on my experiences, I think it's especially important. So I'll tell you a little bit about my background to start. I was born and raised in Los Angeles, and like most kids in Los Angeles, I knew I would grow up and be a famous Hollywood director. I'm sure you've heard of many of my movies. Unfortunately, although that's what I went to school for, it didn't work out. But a funny thing happened in that at the studios I was getting work where they would barely pay me. They would say, hey, you're pretty good with computers, right? Do you think you could fix my laptop? And so I realized maybe my career was going to follow a different path. And the first job I took transitioning into IT, or information technology, was at a company called PDU. And this is a famous company that actually, our work there may have touched all of your lives. Just by a show of hands, how many people here won a trophy doing anything? You guys? Yep. Cool. So PDU, this company actually invented vacuum metallized trophies. And what I mean by that is plastic trophies that look like gold, right? Like we've all seen those. This is actually the company that invented this, and they're the world leader in shipping them. And I really like their logo here because it says availability. And as a system engineer, availability is something that I'm passionate about, and I hope all of you are as well. But I do have a little confession to make. When PDU says availability, what they really mean is that the warehouse is full and the trophies are ready to ship. So a little bit different, although we did build quite a nice online presence there, and it still exists to this day. So from there, I went to a company you may have heard of called Steinberg Software. Steinberg Software, based in Germany. And I worked in the Los Angeles office, though. And this was my first real experience operating online services. This is quite some time ago, back in the 90s. And one of the things we had, these are musicians, mostly the customers of Steinberg. They make a product called Cubase, Wavelab, things like that you might have heard of. Well, when someone's trying to finish an album that they're going to ship and the software is not working correctly, they want a bug fix. At the time, the only way we had to get them these bug fixes was to put a floppy disk in the mail. Yeah, a long time ago, right? And you can imagine most people's reaction when I say, hey, no problem, I've got the fix. I'll send it right out. If you want to pay for next day shipping, we could do that. Otherwise, I'll just drop it in the mail. So very quickly, we realized the way to service our customers better at Steinberg would be to set up some online stuff. So we set up an FTP server. People could just go there and download the updates and not have to worry about getting them in the mail. Only it was the late 90s, and a lot of our customers said, what's FTP? Oh, it's on the internet. What's the internet? Oh, okay. So we set up a bulletin board, and we could give people instructions. Do you have a modem? Okay, you can dial in, you can download it directly. But it was a great experience of learning what is it like to make something that people are going to rely on, how do you keep it up and running, what kind of trouble you can run into, even in a very low volume, low traffic situation. So I went from Steinberg to a place called Guru Labs. And Guru Labs is a small consulting company, but with clients globally. And this was really a great experience to start dealing with all kinds of different companies, with all kinds of scaling and infrastructure and tech problems all around the world. And I really do mean all around the world. I woke up one morning, and we're a small company. There were 3 of us that were the primary consultants. The boss came in, and he said, hey, everybody draw a straw. I said, what's going on? Hey, just draw a straw. Okay. We pulled them out. On the end of each one was a continental region. And I pulled out Asia. I was like, oh, okay. So guess what? You're going to Hong Kong. All right. So got to spend some time in Hong Kong, training folks from the whole region. Awesome experience. Really got to, again, just learn what kind of issues folks face, help them troubleshoot, learn how to really deal with just a wide variety of unexpected problems, because you never know what you're going to see when you're doing consulting. And at that point, I realized, and we're talking now 1999, that I really liked Linux, Unix, open source. All of this stuff was stuff that I feel really passionate about. I just think it makes sense. And I also kind of really didn't like working with Windows. I don't know how you guys feel, but especially back then, wasn't such a great experience. Windows blue screens all the time, this kind of stuff. And I thought, I'm having so much fun working with Linux. How could I find a way to have a job where I only have to use Linux, and nobody's even going to suggest to me that I have to use a Windows laptop or something like that? I said, aha, I will apply for a job at Red Hat. That makes sense, right? They're certainly not going to run Windows. They were one of my clients, and I ended up going with Red Hat full-time. Had a fascinating experience there, first working in professional services and training, so again, working with a wide variety of customers. And then around 2005, I got an interesting assignment, and I'm both extremely proud and a little bit embarrassed of part of it, but I'll share both with you. So they called me in, and they said, we want to get into this virtualization thing. If you guys remember, it was new back then. And they said, OK, Joshua, we want you to dig into this, build some stuff for us. So I built the virtualization certification program. I built the virtualization training. And then I built the virtual training platform that Red Hat operates. And to understand what this was, again, now we're talking back in 2005, 2006, Red Hat training I've always been very proud of. Anybody here ever taken a Red Hat training course? Just curiosity? A few people. What I'm really proud of about it is that it's very hands-on. So you go into a room that's rented somewhere, a classroom. There are computers set up for everyone. You get full real labs that you do with the actual software you might be using in production. And I always was really excited about this, really proud. And they gave me this challenge. They said, can you take this lab environment and move it online? And they probably would have said, can you put it in the cloud? Only it was 2006, and nobody knew that word yet for online services. But I said, yeah, challenge accepted, and built this with the help of some other very talented people, built this virtual training platform that allowed to duplicate this classroom experience using virtual machines you could remotely access through the web quite some time ago, and they're still running the platform today. I'm really excited about that. So that's the thing I'm really proud of. The other thing is that right around 2010, I get called into a meeting, the executive boardroom, and they said, Joshua, your virtual training stuff has been really successful. We would like you to design curriculum for the cloud. And so I said, well, okay, what does that mean? Like, what does teaching people the cloud mean? And again, this is, 2010, so it was still kind of new. And they said, we want you to tell us what that means. Okay, I'm always up for a challenge. And in this case, I actually am the one who defined what cloud means for Red Hat. And that's the thing I always feel a little weird about, because it just felt like such a buzzword. I mean, now it's like the word we use for everything. But at that time, they said, define what this means and how we can teach it to people. And I took a very infrastructure-focused approach. So I've been doing a lot of stuff with internet cloud for a while. After about 10 years at Red Hat, off and on, I did leave to a startup. It didn't succeed, but that's how you learn. Came back to Red Hat because I had such a good time. But at some point after 10 years, you're looking for a bit of a change. And I had, now early 2011, been browsing the web and looking for a place actually to have a host a website, and I came across this site called Tumblr. I'm sure most of you have heard of it. And you go to the About page, and it's this cute little company with a small group of people eating lunch together every day, and they're really proud, and it's like maybe 20, 30 people. And it just reminded me of the old days at Red Hat when it was small, and you really could kind of dream up a feature of something in the morning and have it built and rolled out by the end of the day. By the way, not something you do at web scale. And then the craziest thing happened. Like 2 weeks later, a friend of mine called, and he said, how would you like to join the team at Tumblr? Would you be willing to come and be a system engineer? And I said, well, how big's the system engineering team? He said, are you going to join us? Because then the team will be 2. I said, oh, okay. So I said, yeah, awesome. So I took the gig at Tumblr when, again, we were about 30, 35 people, and started as a system engineer. We had a lot of work to do when we first got there, because as a site that was started with a small group of people who were really more passionate than they were high-skilled engineers, built something really cool, but then tons of users flood in, and now it's barely holding up. I describe the experience as sort of like someone gives you a boat and says, hey, it's 98% waterproof. So all you got to do is, have a friend that keeps dumping the water out and you'll be fine. Well, that works for a while, but as the more and more people pile in, you got to fix things, otherwise it's going to sink. And so spent a lot of time at Tumblr building the infrastructure that still runs it today. And we'll talk more about that as I get into some more specific examples. I had a great time at Tumblr, quickly rose to be the lead system engineer, and then, as Rolf mentioned, became the director of infrastructure as we grew from a team of 35 people to 350 people. Which is kind of insane, I'll tell you, because I used to be really proud. I would be someone who would take new hires on a tour, and I knew everybody in the company's name, until one day I knew I would never know everyone's name again, because it just got so big. And then Yahoo came along, and you may have heard, Yahoo bought Tumblr. And suddenly you go from being 1 in 350 people to 1 in 17,000 people. And right around that time, I had been getting bugged by a recruiter, and I had been ignoring that recruiter because I liked what I was doing. And then I thought, well, I'm not sure I want to work for Yahoo, so let's see who that recruiter's calling from. And it turned out that that recruiter was calling from SoundCloud. And I said, hey, that sounds exciting. They have a lot of similar scale challenges to work on. A bit bigger than when I joined Tumblr, but still plenty of good stuff to do in the infrastructure. So I joined SoundCloud as technical director or director of infrastructure. Had a great time working there as well. After about 2.5 years, we really accomplished a lot. We got things quite stable. Huge site. The amount of traffic that is going through SoundCloud of people listening to music all the time is kind of mind-boggling. And so after a good stint at SoundCloud, a former colleague of mine who I'd been worked with at Tumblr, and you'll hear him speak a little bit later today, he called me up and he said, hey, you heard of this company called LeaseWeb? And I'll be honest with you, I said no. And he said, well, you really should, because it's a really great place to work, and I think you'd have a good time here. And so I came down, we talked for a while, and I joined the team at LeaseWeb, and I'm really excited to say that I am the head of product engineering with LeaseWeb. I've been here since last December. And so that's kind of a quick introduction to me. So thank you for listening. Now we'll talk to you about what I consider the 7 deadly sins or 7 engineering sins. So what does this talk about? Well, I don't mean to sound religious. I'm not a particularly religious person, but I really love this idea that you can't save a sinner until they know they're a sinner. Right? So in other words, if you're going and designing a website and you're building your application and it's brand new and you're just doing whatever you think is best, you could be doing things completely wrong, but at a low volume of traffic, everything will work fine. It's like you can't do anything that doesn't work. I mean, something might obviously not work, but you can do all kinds of stuff that under low load works fine, but under heavy load, that's where you find the leaks, that's where you find the things that break, that's where you find the stuff that falls apart. So my goal in this talk is to help all of you that are sinners see that you're sinners, and then help you avoid that. Everything that I'll share with you is based on real events, actual terrifying stories, some of them that happened. Really only one, but you'll see. But I have very slightly fictionalized them just to, protect the innocent or perhaps the guilty, however you want to look at it. All right. So we'll go through a series of case studies. And this first case study is a data center management platform. Now, this is actually from when I was working with Red Hat. This is one of my clients that I consulted with. You can use your imagination. I'm not going to say it's Yahoo, but it's Yahoo. So when Yahoo built their first data center, and this, as someone who personally built a data center with Tumblr, something you find really quickly is there's really not, and especially back then, there's not a lot of good open source for just managing your big pile of hardware and automating and keeping track and provisioning and doing all that. There's some commercial stuff, but there's really nothing off the shelf because you need this mix of inventory management and automation and tracking. And so Yahoo, like most places, I'm sorry, not Yahoo, built their own system to do this. And it makes sense because if there's nothing out there, you build something that meets your needs. Well, then it came time to build the next data center, and they're growing. It's very exciting. Well, one of the things that happens, how many people here have written a piece of software, by the way? Okay. Most folks, I hope so. I mean, anything counts, a shell script, whatever. Well, whenever you write software, some of your opinions are coded into that software. That's just how it works. We all have ideas about how things should be, and when you create software, you kind of put them in there. And when you work with a large enough group of people, you will encounter people who have very different opinions about how things should work. I'm sure you've experienced that, and sometimes you end up arguing, whatever. So when Yahoo came around to build their second data center, sorry, did I say Yahoo again? All right. So the team there had some issues with the first data center management platform. And here you sort of hit a fork in the road. You can say, let's take that existing platform, let's add some features that we'd like that maybe we're missing that would enable us to manage our data center more efficiently. Or you can choose the other fork, which I call the sinful fork, and this is the one that they chose. And so what they said is, hey, you know what? I don't even want to deal with upgrading or enhancing that existing platform. We're just going to build a new one from scratch in the second data center location, and then, of course, we'll go back to the first one and we'll put the new software there so it'll all be there. And if you recognize that as a picture of a wheel, this is the first sin, which I call the sin of pride, or refusal to use tools not invented here. And the here is here, personal, right? So your company, even in this case, has a set of tools, and you refuse to use those because you didn't personally write them. This is one of the things that probably drives me the most crazy. Now, sometimes it comes from an innocent place. You have a software project you need to do. You aren't aware that for 30 years there's been a standard open source solution, so you don't use it. Instead, you make something from scratch. And sometimes that's fine. Sometimes that's really not okay, especially when you have a lot of burden of maintenance and it's not your core business to be building data center management platforms. Now, if that is your core business, then absolutely invest your time in it. But especially when you already have one, to sit there and write another one, that is just sinful, I think. And sometimes it can go really bad. Like at a previous company, I saw an engineer who was really excited. He was writing this code in Ruby. And he said, let me show you this amazing thing I did. And I said, I got bad news for you. This already exists, and it's called grep. True story. So what is the result? Well, flash forward. This company now has many data center locations, 8. And oddly enough, they, and I kid you not, have 8 different data center management platforms. Now, when you work in a global scale company like this, and you're writing code that's going to automate the management of your services, you want global redundancy, right? That's a big part of web scale. If the data center that you have in Berlin goes down, you want all the traffic to fail over to the one in Amsterdam or whatever. So this means you have to write automation that spans multiple data centers. So that means, of course, if you work at this company, you have 8 different APIs you may need to talk to. And so, of course, then now a weird forest starts to grow of people who are creating abstractions that sit in front of these APIs. So, oh, you only have to talk to this abstraction. Well, I don't like your abstraction. I'll make my own. And what do we say? It's then, turtles all the way down. So, please, I beg all of you, if you have such a strong sense of pride and your individual talent that you have to write everything yourself, please quit our industry. Sorry, that's just how I feel about it. All right, next case study. So let's call this Blue Cap Enterprise Linux. I think you could follow along. So I mentioned professional services and training, and a big part of what we did, and what the group still does, is document and technical manuals and generating all this material. And one of the things you find when you're writing these sort of technical documents is that a lot of times people might want just part of one document. You write a 300-page document that talks all about system administration, and somebody just wants the chapter on network administration. So this is one of the challenges that comes up. So a lot of companies will employ some sort of standardized document toolkit, and in this case, we decided to use a tool called DocBook. If you haven't heard of DocBook, it's an XML specification for writing technical documentation, and the goal of it is that you build a single code base, and from that single code base, you can then generate a web version of your documentation. You can generate a press-ready version of your documentation. You can even generate sort of a modular version and say, okay, I want to pick 3 or 4 sections and just make that into something press-ready. So it really gives you this amazing flexibility of producing documentation. The thing about it, though, is that DocBook is just a specification. You have to build tooling around it to actually automate those builds. And if you want to do important stuff like translation for multiple countries, you also have to build some tooling to export your translation objects and put them back in and so forth. So this all made sense because other parts of the company were already using DocBook. And so we could piggyback on their tools, kind of sense a theme here, and be really great to share the support burden and so forth. So we assigned an engineer who worked in our department he really stood up for this. He said, I want to work on this tooling. And tooling this up should have been a 2 to 3 week project. You're really just building some automation, kind of deciding where you'll lay out your files in your repo. Nothing complicated. You're not solving anything really. You're just setting things up. So we brought this engineer in, and he goes to work. And about 2 or 3 weeks later, we check in, how's it going? And he's, it's great, but I need more time. I'm not quite there. And I took a look at the code. This is a fictional example, but the part I'm specifically concerned about is that, in yellow. This is supposed to be a small amount of tooling for using DocBook. And when I see something like this in the code, things turned on when DocBook is disabled, I'm thinking, how could this tooling and automation for DocBook possibly work when DocBook is optional? What is this guy building? And digging deeper into the code, you could see that this person, I asked him about it, and he was very open. He wasn't shy at all. I do value transparency, but he said he's always been passionate about typesetting. He's always been passionate about the web. And he's always felt that DocBook could be improved. And so what he built was a system that was his sort of dream publishing system that he'd been probably carrying around in his head for years that, it could use DocBook as an input if that was required, which was the only thing we actually wanted. And he had his own sort of version of XML tags that he thought were just better than the DocBook specification. Which, if you think about that, if you have people that can follow a spec and write the material, there's good reasons to have a standard. Or the best way that I explain this, it's sort of like we told him, hey, I need a lamp for my desk that lights up so I can read. And about 3 months later, he marches in with a giant killer robot that has a light bulb for a nose. I said, well, congratulations. You have committed the sin of envy, or as I call it, desire for a more exciting project. And this is something that you deal with a lot. I love solving really complex, really interesting software problems. I mean, if you folks that raise your hand that you do software development, you know that feeling when you create an algorithm that just solves your problem elegantly, and you work on it and you run it and it all works and it works nicely, and that's the best. If you work with me, you probably know I would say at this point you're like, fuck yeah. But then there's all the rest of your application you have to write. All the boring standard parts that no one wants to deal with, error handling and, okay, error handling is very important. But just the boring stuff, the login page. How different is it? How many people have written a login page of some kind? How many people have written 2? Did you find it equally stimulating the second time? So this is a common feeling of, I don't want to do this boring stuff. I want to do something exciting. And you have to kind of realize, well, there's customer value we want to deliver. There's important things we want to do. And so sometimes you got to just put away that feeling of excitement or, that desire, take it home and do an interesting hobby project, or, wait till the next big assignment. So result here, we ended up with an undesired new bespoke document publishing system. And I said, we'll work with DocBook, maybe not really. Well, here's the best part. So when the guy delivers the solution, I get this call from my boss who says, we have a problem. Well, what's the problem? In 3 weeks, the source material for our international publishers needs to get to them, which means in 1 week, the portable object files that get translated need to go to the translators. I said, yeah, okay, it sounds fine. He said, well, yeah, there's one problem. This new system we have doesn't output anything but English, and it's hard-coded, like into the code, because the guy wanted to do fancy rendering. So like at a chapter title, instead of saying the word chapter and the number 1, and normally you would output a translation object, and people would translate the word chapter into various languages, and it would still print nicely. This guy hard-coded, like anywhere the number 1 appears, just replace it with ONE, which is a nightmare if you need to suddenly do translations. So I was handed the assignment, can you get this fixed in 1 week? The answer is yes. It was not a fun week. And basically the fix ended up being throwing away 90% of his code and adding a couple of shell scripts to sort of Band-Aid patch it to working till when we had the time to actually redo it and retool it up and so forth. By the way, if you're interested in this kind of stuff and publishing, the tool that's now open source that is used by this enterprise Linux company is called Publican, and it's available and anyone can use it. And it's a nice, clean DocBook implementation. So highly recommend checking that out. So our next case study. And this is one of the things that is most important. Now, we'll say this comes from a company, well, let's call it Humbler. Instrumentation is critical. And the more you work at scale, the more important instrumentation is. And what do I mean by instrumentation? I mean, metrics collection, dashboards to visualize them, seeing what's going on inside your software. I once gave a very passionate talk to the team at SoundCloud talking about if you don't have instrumentation, and I came up with this analogy. I thought it's sort of like riding a motorcycle with a blindfold on. Really fun, right? As long as you don't crash. But that's really what it's like. When you walk in somewhere and you say, well, how is the site doing right now? How many transactions are we processing? How many errors are happening? If you have no way to visualize this, you don't have this information, it's really hard to stabilize your site. So we had a big effort to get metrics collection going. And at the time, you're looking into high-scale systems, and the typical tools out there, I think Graphite was popular, but it really couldn't scale up well. So some of our team got together, and they looked for tools, and they found this thing called OpenTSDB. Anybody heard of that? So you set up, pretty cool stuff. You set up a Hadoop cluster, you set up HBase, you set up OpenTSDB, and then you send your metrics to it with tags. And then you query it, and you get back results on these time series. And we had an in-house team build a nice little dashboard to go with it, and we start sending all these queries in there. And hey, it works great. Then the network team says, we could really use this too. We would like to capture network metrics. And at this point, we had approximately 2,400 network ports that we're using to run the site. And they set up every frame should be sent to the metric system on a busy website, as you can imagine. And very quickly, the cluster fell over. All the dashboards stopped working because the cluster fell over. And this is obviously a problem. So what are we talking about here? I call this gluttony, or ignoring scope or capacity. And really quick question. So I know some of you raised your hand before. How many people work as some kind of engineer, tech engineer, system engineer, software engineer, infrastructure, ops? Awesome. I'm glad my people are here. Thank you. Now, also put your hand up if you do capacity planning. I have a little hint. If you raised your hand on the first question and you didn't raise your hand on the second question, you should be putting your hand up on the second question, right? Anyone who does any kind of engineering, you have to do capacity planning, right? You might think, well, the server's bigger than we'll ever need. Sure, if you get popular, probably not. And so every one of us has to do capacity planning, and there's multiple layers to capacity planning, right? It could just be as simple as how much memory will my process use per user, and how much memory does the infrastructure it runs on have, and understanding when I get close to that threshold, I need to roll out more infrastructure. But equally important is capacity planning with your vendors, right? It's easy to think, and we've all probably been guilty of this, it's the cloud. Just throw it in the cloud. Everything will be fine. And actually, I saw a really funny cartoon, comic that reminded me. It was a young engineer going to a more senior engineer, and the young engineer says, "Wow, we had a crazy day yesterday." "Oh, what happened?" So, well, we put a bug in our JavaScript front end that basically almost DDoSed our own back end because of the way the bug worked. He said, "But thankfully, we run it in the cloud. So, auto scale up, no problem." And you just see the senior engineer. And the reason is that, if you're lucky, that will happen. It'll go up. But I was at the NextWeb recently, and I was talking to a couple of startups that ran into this problem, and they didn't have a bug. They just got popular, and they were really happy to say that, oh, yeah, all this automatic scaling in the cloud worked, and we didn't go down. But then we got the bill. And without finding your inefficiencies and just letting things go out of hand, these folks had a site that they were paying about $500 to $700 a month for their cloud hosting. And then the bill came for $50,000. A little bit different. They actually had to turn off user signups, take the site down, and it's not a problem you want to have. You've got to do capacity planning at every level. And so with vendors, let's say you have a CDN vendor or two. It's usually good to have two, but most folks at a high-scale site, you want to have a CDN. If you are then bringing in another CDN, and you normally run them at 10% of your traffic, let's say for a backup, which is a good strategy, you can't just wake up one morning and throw the other 90% onto that CDN. I mean, theoretically you could, but they probably don't run with that wide of a margin of their capacity. So even with vendors, even with cloud vendors, if you know you're going to be suddenly consuming a lot more capacity, give them a call. Just say, hey, next week we're planning to turn this on. Is that going to be okay? Are you ready? Trust me, they'll be happy. They'll help you ensure your own success. Don't surprise them. And that also goes, of course, for internal services. If you were on the team that was running that TSDB cluster and no one told you that this avalanche of metrics is coming, you probably wouldn't be too happy with that. So what was the results? Well, as I mentioned, the sheer volume of network metrics collection knocked it over, killed dashboard performance for everyone, and we had to rethink the strategy of how to track the network. Sorry. There we go. Okay. Next case study. We'll call this company AudioGarden. You can probably figure it out. So if you're not familiar with a timeline service, any kind of social website where people can post stuff and other people can follow those people has some version of a timeline service. So, for example, you log into Twitter, you see the things the people you follow have posted. So how does that get created? Well, if you're brand new, you're making your own thing, you've just got this brilliant idea for some sort of social site, you would take a naive design approach. Probably just say, hey, every time someone posts, we'll just throw it in the database here, and then every time someone comes and logs in to read what they're following, we'll just do a big query and say, hey, get me all this person's followers, and then get me all the things they posted recently, and you'll put that on the website. That works great when you have like 50 users. When you get to scale of a really large website, that kind of approach doesn't work. You need something, rather than something built into the core of your app, you actually need a dedicated timeline service that will cache and will bring this stuff up and perhaps even pre-populate it, depending on this kind of inbox model or outbox model. And if you're facing this challenge, I highly recommend, if you go on YouTube, Instagram put out a great talk on exactly how they built their timeline service. It's highly detailed. Check it out. It's a great example of how to do this. So at AudioGarden, the old timeline service was not keeping up anymore. And in order to fix the problem, we decided we needed to create a brand new, from-scratch timeline service that, using all of the knowledge we had of now how the users use the site, we could build this service, and we tasked one of our brilliant, talented engineers to build it. And he said, oh, this is great. He ran off for a few weeks, did a little research, came back, and he said, hey, this is what I'm thinking of building, guys. What do you think? Everyone said, yeah, that looks brilliant. Go ahead. And then he kind of disappeared. And you'd still see lots of commits. You see lots of activity, but he's sort of off in hiding, working on this. And this sin, lust, or as I call it, premature optimization. Use your imagination how that works out. But I think it's really this trap of lusting for perfection, right? Like you do something and you want to make it perfect. And I got news for you guys. I've never done anything perfect. I think it's kind of impossible. I'm a believer that the perfect is the enemy of the good, if you've heard that. But the real problem here is when you go off for 4 or 6 months in isolation and you build this thing and you're not taking input, the world is changing around you. And if you have not accommodated for those changes, this really well-designed, well-thought-out, brilliant piece of software might not fit the bill anymore. And this is exactly what happened. Only the problem really hit because the software came, was delivered, migrated it into production, got it live, saw that it worked really well, and then one of the teams came and said, hey, what about this other feature where we can inject featured things into the timeline? Oh, that wasn't in the spec. And it was a weird situation. Everyone, what spec? Like, oh, the spec I showed you 6 months ago that you said looked really good. Well, you can imagine how that goes. And the result here is that by the time this thing was migrated live, there were critical features that weren't there, even though this is a brilliant piece of software. And in fact, some academics in the high-scale space wrote about it and said, wow, this is an amazing thing. It's open source. It's out there. It had to be retired after 2 months because it had to be replaced by something that could actually meet the requirements that had currently happened. So it's really critically important that you don't try to solve problems you don't have, and you really work with your stakeholders so you can avoid dealing with this kind of thing. So what should be easy? Removing a driver, right? That should be the easiest thing in the world. And we're back to Tumblr. And this is the terrifying story I warned you about. It starts simple enough, right? So we were running at this time approximately 1,200 to 1,400 servers to run the site. And we're running them in our own shop, and we relied heavily on remote and automated management to be able to do that because we had a small team. And one of the things we found was these particular servers, they were all the same model. I won't tell you the manufacturer just because, I'm trying to be nice. But I'll show you a picture later. All right. So we discovered, these particular models have IPMI interface. If you're not familiar with what that is, it's an out-of-band way to access and manage the server, so you can reset it, you can get stats from the motherboard, things like that. You could reach this over the network, but there was also a driver, a Linux kernel driver, you could load on the machine itself to allow it to speak to the IPMI board from the host OS. Right? So not from the network, but directly from inside the OS. And we experimented with this a little bit, and we discovered that this driver was a bit unstable on these machines, and under some circumstances, it could deadlock the motherboard, right? Just completely deadlock the server, but it would never happen if this driver wasn't loaded. And we did not rely on this driver for anything we were doing. We had only used it for some experiments, so we knew we didn't need it. So we got one of our engineers, and we said, hey, build a plan, come through, configure every server so this driver is blacklisted and will never load. And this is our solution to having this driver cause problems. So that's the easy part. So he builds this, he deploys it out, pushes it to everywhere. No problem, it's blacklisted. Well, it turns out that some of the way he wrote the script to set this up, we detected that it was on many machines actually loading the driver, which that's not good. And so we said, okay, well, we're going to give you this follow-up, a cleanup assignment. Just go across the entire fleet and unload the driver. Sounds simple enough, right? Just, remove it. So he goes and he gets his own development machine, and he tests his code, and he unloads the driver, and everything works fine. He grabs a couple more machines from production, unloads the driver, and everything works fine. Well, the thing that we didn't know was that this was the uncommon case. And he just got, it's like the day to buy a lottery ticket, right? Like you pick 3 machines, and those have no problems, but that's weird and uncommon, and you don't know that. So after 3 machines, this person has built some confidence and says, hey, let's just do it. Boom, and hits the deploy button to 1,200 machines. And to make matters even more exciting, this person was working remotely that day. So here we are sitting in the office looking at our wonderful dashboards we've made, and we start seeing weird errors piling up everywhere, and then servers just dying left and right. And then he sends a chat in our IRC ops channel. He says, hey, I think I might have made a mistake. I said, yeah, well, what's going on? And he said, yeah, I think, this unloading is causing these machines to deadlock. And so immediately we make the call. We say, okay, put the site in read-only mode so we won't lose posts. Everything will be okay. I guess we got a little bit lucky in that the 800th machine to deadlock was the machine that sends jobs to all the other machines. So once that one died, it couldn't kill the rest. So 400 or so machines were spared. But to make this worse, so now the site is down, right? Because with this, we just couldn't sustain that much loss of hardware. It's in the news. By the way, I'm sure you've heard of a site called BuzzFeed. You ever had a job where BuzzFeed reporters harass you while you're trying to fix something? Yeah, it's pretty exciting stuff. Yeah, and then the next day I get a call from my father. Hey, see in the news, your site went down. Rough day? Said, thanks for the support, Dad. All right. So what we discovered was that the only way to recover the hardware was to actually physically power off the machines completely, right? Because you can't use the IPMI because that's frozen. So you have to actually remote power cycle. And, most places have remote power cycling, so that's not a big deal. But so this is not the exact model, but it is the same manufacturer. What I want to point out is that these they're sort of like kind of a blade, kind of not. They're 4-in-1. So what you see there in yellow that is one of the servers, and there are 4 in each chassis. And those 4 servers, for redundancy, share 2 power supplies, which you can see there in red. Well, guess what happens if you cut the power to this chassis? You don't power cycle 1 server, you power cycle 4. And in our case, some of the remaining servers were actually important. There's a SQL master there, there's, whatever here. Like, we didn't want to deal with having to randomly kill new things just to recover the things that were dead. So what that meant was everybody pile in the van, drive to the data center, and we spent the whole day going around tracking which machines are which, physically yanking them out of the chassis to get them to power cycle and slapping them back in. Awesome day. So hopefully you can avoid that. Well, what is this all about? Right. This I call the sin of wrath, or insufficient testing. And usually because one will lead to the other. I could be wrong, but I'm pretty sure the owner of this building did not intend that to be their display. Who knows? So as I mentioned, approximately 800 physical servers required hands-on touching to get the site back online. But eventually, about 8-9 hours later, we were back online. Everything was okay. A lot of hate on Twitter, but we survived. All right, here, next one. We're back to this enterprise Linux company. And this was very simple. So you're rewinding the clock back. They're putting out this enterprise Linux. And Linux is free, so you got to figure out a way to get people to pay for it if you want to be in business. And the thing that they come up with is, well, we'll have this incredibly cool management service. The enterprise network, whatever you want to call it, and you'll be able to register machines and have a nice control panel and see all the aspects and do automated builds and do updates and really, good management stuff. And this was very successful. But the next thing that happened was you get certain large-scale customers that say, hey, we want that thing you're running as a service, but we want it on our own box in our data center because we don't want to have to rely on all of our thousands of machines connecting to the internet all the time just to be managed. And that's reasonable, right? Well, the problem here is that in addition to making their own CMS, which at the time was reasonable because there weren't a lot of choices, we're talking before WordPress and all that kind of stuff. So they built this custom CMS, but they needed a database, and because it was being built as a service, it wasn't a thought to be something to sell. And I don't remember exactly how this happened. I think maybe a couple executives were on a golf course and shook hands, and somehow we were in bed with Oracle. So they built it to use Oracle, which is okay, except that when you looked into the code base, all the database interactions were hard-coded. Yeah, which is really bad. And so this is what I call greed, or making stuff tightly coupled or monolithic. If there's one piece of advice I could share with you to make scalable systems, the most important thing it is this: decouple your data source from your application code. They should not be in the same code base. Write a thin wrapper around whatever you're using for data persistence. Write your application code to talk to that in some standard way, like JSON probably. And this way, when your needs to store data change, you can change the back-end storage, and you only have to rewrite this one little thin abstraction you made. Right? You don't have to find all the places in your code where you hard-coded Oracle queries. My God. The result, it took years to clean this out. Years, I kid you not. It's because we wanted to do an open source version, and no one's going to take an open source project that requires Oracle. So you had to really clean this out. It took years. So please abstract all of your data queries. Keep it separate from your application code. All right, so next one. I kind of just want to tell you who this is. It's funny, and it's so long ago, it probably doesn't matter. So I guess I'll just tell you, it's not AOL, but it's AOL. All right, so a little quick history on AOL. It was one of the first big online services, at least in the States, and they started on an architecture called Stratus. And if you're not familiar with Stratus, it's basically like these big mainframes that are massively parallel, massively reliable. They phone home and order their own replacement parts when something goes wrong, like you don't even deal with it. Everything's redundant, and a technician shows up at your data center and says, hey, your machine called, it needs a new whatever. And it's great, because they're really reliable. Problem is, they cost about $1.5 million per unit, which is a really shitty unit of scale. Because if if your occupancy is 99% on your Stratus, and then you go to 100%, you got to buy a whole nother one to get to 101%, right? Like you have to spend another $1.5 million. So realize this is not the way that this business is going to grow. So they decide instead, let's use Unix. So we'll get these, relatively low-cost Unix machines, HPUX at the time, and then eventually CentOS, but first HPUX. And so one of the old-school engineers who knows Stratus really well, he writes this little API service that just runs on the HP box and provides a network interface for all the other HP services that are running there to interact with the Stratus. So this is sort of a communications gateway. Stratus did not use TCP/IP very much. They had just a very thin implementation, and then their own protocols on top, so this gateway handled that stuff. So that's great, but now you get a few years later, and HPUX boxes seem like a really expensive, bad unit of scale, because you're like, hey, we could just get PCs and run Linux. Okay, sure. So now it's time to unpack this, to get a Linux version to replace these HP gateway servers. And no one can find the source code, like to this thing. It's just missing. It hasn't been touched for years because the thing works so well. To make matters worse, this was an early employee who had a ton of stock and retired to some island somewhere. So you couldn't even reach this guy. And this is what I call the sin of sloth, or avoiding maintenance and/or documentation. If you've been in the industry long enough to get a bit of gray hair, you probably have done this to yourself. Anybody done this? Like you wrote something that worked great, and then like several years later, you need to dig into it to make an enhancement or a change, and you look at it and you're like, I don't know what the hell I was thinking. I have no idea how this works. And you didn't create the documentation. So, I'll say this. To me, documentation is like a love letter to yourself in the future. In this case, it took months of work and multiple outage-causing failed attempts to actually restore this gateway service. Best avoided. So I hope you can take away from this some advice that will help you perhaps avoid being a sinner and build really awesome, scalable stuff that you can share with the world and not have to deal with problems that you create for yourself. And I'll leave you with a final thought, is that a problem is a chance for you to do your best. Thank you.
Thank you, Joshua. Are there any questions? We have a nice catch box, so we throw that through the room.
No questions?
Okay, well, I have one, Joshua. He's told us that you worked for Tumblr, so we all know that there were 65 million passwords, stolen,
Yep.
borrowed. Do you have them in your pocket, or?
Have them in my phone.
Good.
No.
Was that one of your sins, or?
So I can honestly say that this was after I left the company. So. So they pinned the breach down pretty well, and it was after I left the company. But there are certainly things that you can do better, and I'm sure some of the stuff that we did could have been improved upon. So, yeah. Any other questions? Internet guy in the back.
Wait, I will run.
Does capacity planning really matter if you're just getting started and don't have any users yet?
So that's a great question. I would say the answer is both yes and no. No in when you're first building stuff, you're just slapping it together, you're making prototypes, you're trying to get that working, just get it working. But it kind of does matter. The tricky part is that you don't know the inefficiencies or the pressure points in your software until you put it at load. So do load testing, find out where you're going to run short of capacity and be ready, even if it means it's 2 years from now when you're going to need an upgrade. So at first, it's something you should always be thinking about, even though you probably don't have to take it too seriously right away.
All right. Thanks, Joshua.
Cool. Thank you.
Thank you, and don't forget to give his feedback.